Well, hello everyone. I think we might make a start. My name's Catherine Daniel and I'm a professor in the 3 Institute in the ANU School of Cybernetics and convener of the Master of Applied Cybernetics program. I'm joined today with staff from some of our courses and administration of the program, Dr. Zena Assad, Dr. Mina Hanain, Anna Goshen, and Kate Roffey, so that we can provide some additional detail on the program and respond to any questions you may have. First of all, today I would like to acknowledge the traditional custodians of the land from which I'm speaking, the Ngunnawal and Ngambri peoples, and pay my respects to elders past and present. It's land that's always been sacred and never ceded. And it's perhaps sometimes easy to think that technological systems and the ways we make sense of them are modern inventions and artifacts of the industrial age. But for us, when we talk about the future and about technological systems, we need to build awareness that we're in a place where humans have been making the future and making technology for millennia. The complex systems that First Nations peoples have created and sustained, and their insights and knowledge have profound resonances today. And amongst these nations, people have been our first engineers. And we're really lucky to work with some amazing students and traditional owners from different countries across the continent who continue to be at the forefront of developing culturally safe, sustainable and responsible technologies and communities. And I think this provides important context and part of our program. And so before I present our program in a bit more detail, I have a message from Distinguished Professor Genevieve Bell, the director of our school, to introduce you to the school where the Masters is hosted at ANU.
ANU was founded in 1946 on the lands of the Ngunnawal and Ngambri people. It was founded in an optimism about the future in the wake of World War II. It was committed to bringing together all kinds of people to build something new. On the other side of the world, at the very same time, a group of people also gathered to plan a better future. They called theirs Cybernetics. These two ideas have a lot in common. It's more than just coincidence, it's serendipitous. In 2021, ANU founded a brand new school, the School of Cybernetics. It turns out a cybernetic approach is still very relevant today. Cybernetics is about how we think about complex systems and how we balance technology, culture, and ecological dynamics. Cybernetics is at the heart of our work, and it's a tool that sparks new ways of thinking and doing, and new possibilities for the future. My team and I at the School of Cybernetics are establishing programs that blend education, research and engagement to create a new generation of critical thinkers and critical doers who are ready to tackle the challenges of the 21st century. Through our programs, we're building a new branch of engineering to safely, sustainably and responsibly scale AI and cyberphysical systems. We focus on systems as a unit of analysis and as a driver for action for those working with complexity, and we're generating new approaches to shape the future through and with technology. Cybernetics is an idea that has held through the years, and we have the opportunity to carry it further now. Our obligation and our challenge is to tell good stories about a better set of futures and to simultaneously break open the present enough to make those futures possible.
So thanks to Genevieve for giving that bit of context. And what we wanted to do now was to move into the program from these important elements of context. What we'll do today is I'll briefly highlight where you should be able to find most of the information about the 2022 application process. Then we'll provide some additional context for the Masters, building on Genevieve's description of our need to develop critical thinkers, doers and future builders who can work with the interwoven systems that incorporate technologies, humans and their cultures and the ecologies and environments that sustain all of these. And I'll then dig down into an overview of the program and the courses that are internal to it. And then we can open the session to Q&A. And I have a couple of the conveners of those courses, so you can ask more of those questions in detail. Just for how we're running this, please put your questions in the Q&A box. And then we'll slowly go through them at the end of this presentation. So the ANU Master of Applied Cybernetics is the world's first graduate program that focuses on the challenges of ensuring AI-enabled cyber-physical systems are safe, sustainable and responsible. And the program's an immersive cohort experience where the students get to help us build the new branch of engineering, and I'll explain what this means in a minute. It'll be full-time and on campus in 2022, obviously COVID-19 permitting. And the master's program commences in Canberra at the Australian National University in February 2022. And hopefully you'll be able to find all the rest of the information about the program and application process in the application pack and FAQ document that's on the website. And in a minute, as I mentioned, I'll take you through the parts of the program, but first I want to take you through some of the elements of its genesis, as it should help you to see the ambition of the program and the areas that are focused on across the courses, and also thus what the program doesn't aim to do, and we can talk about that more in the Q&A. So to begin with, I want to think about some of the recent revolutions around machines and what is powering and transforming our society, because this is important history for how we think about the current transformations with big data, artificial intelligence, and the smart systems that we're finding increasingly around us. If we think back to the first industrial revolution, this was powered by water. Steam engines were miniaturized, taken off the mineshaft. They were put on trains and they were made to be mobile. And this led to us needing to create entire transportation systems that transformed society. These systems transformed how we think about time. For example, Greenwich Mean Time was developed to allow the trains to function, and how we regulate economies for society's equalities or inequalities. The fact that there were third-class tickets were obligatory when the English trains were developed. And at that stage, there weren't particular people who had a lot of the skills to build, imagine, and transform these systems. But over time, through the first industrial revolution, engineering schools were created, like in Paris, the École Polytechnique that was formed after the French Revolution to create a new collection of leaders who would be able to build and transform society. And these are the first engineering graduates in civil, mechanical, and military engineering who were specifically trained in an expansive, interdisciplinary way to support the building of the new French state and these transformational systems. So if we think about then the other revolutions, the second wave of industrialization with electricity and mass production, this also required a whole range of new skills. It required different types of bookkeepers, and you had the development of business schools and also electrical engineering to understand and build these systems at scale. And when we think about the third wave of industrialization with information technology and computing, this again required different skills. Not one person had all the skills required, and we had to create new formalized systems of education to develop computing and software engineering to be able to build and manage these systems appropriately. And what we're seeing now is that computing is being miniaturized, it's being put into a range of what we now call cyberphysical systems that are growing increasingly intelligent because of their interconnections and their ability to use real-time data to make decisions increasingly autonomously. And as we think about this particular group of systems, we also believe that we need a new range of inter or transdisciplinary skills and professionals who can think about these systems holistically and take them safely, responsibly, and sustainably to scale. So that's what the new branch of engineering is about. And to help with this challenge, we see cybernetics as a really helpful approach and inspiration for the development of new conversations and practices required for the building of this new branch of engineering, as it inherently conceptualizes the social, the technological, and the ecological as entwined, and more importantly, perhaps, in its ability to support the training of critical thinkers and doers, as Genevieve was mentioning. So what is cybernetics exactly, you might ask, because obviously it's a program of applied cybernetics. Well, for us and for many others, this is not a simple question with a straightforward answer. And we consider that it's the multiple histories and evolutions of cybernetics, its ancestors and its children and cousins that are actually important, as they allow us to understand where cybernetics came from and how we might appropriately translate its values into today's AI-powered context. So to give you a bit of a background, looking at cybernetics theoretical roots, it's derived from the Greek word for navigation, or those who steer, and was already used by Plato to think about governance. And then if we think about those waves of industrialization I just spoke about, Just following the French Revolution and in the throes of the first water-powered industrial revolution, the Frenchman André-Marie Ampère, after which the AMP is named, denoted cybernétique in 1843 as the art of governing, reflecting the close intermingling of politics, philosophy and science in managing that new French state. So these rich political concepts still hold value when brought together with those discussed through the transdisciplinary Macy's conferences and Norbert Wiener's post-Second World War cybernetics that Genevieve mentioned, that Norbert Wiener considered as the scientific study of control and communication in the animal and the machine. And so since then, there have been a number of waves of cybernetic theory and practice developed over recent decades. And these have seeded or been paralleled in the development of many systems theories. So cybernetics, as it's understood today, and as we teach it in the program, thus seeks to overcome a lot of the unitary or linear thinking and mechanistic patterns. It supports us to move beyond simple step-by-step cause-effect models of the world to those of higher complexity that allow us to consider multiple interdependencies and feedbacks, thereby providing a space for learning about different systemic and holistic ways of knowing, being and doing at a personal, organisational and societal level. So with its richness of multiple histories, we see cybernetics as a really helpful conceptual and actionable framework for developing the skills needed for the new branch of engineering, managing AI-powered cyberphysical systems in the world. And so this gets us to the master's program that we've been prototyping since 2019 through the 3A Institute and now the School of Cybernetics to teach the new branch of engineering, as yet unnamed, into existence. Specifically, our program's called the ANU Master of Applied Cybernetics, and it's run as a small cohort generative program that aims to experiment with those different approaches to complex systems. It leads students through the why, the how, and the for whom of technologies to give all of our students the skills they'll need to safely, responsibly, and sustainably scale AI-enabled cyberphysical systems, and the skills potentially to resist certain instantiations of scaling where necessary. The program is based on a principle of inclusivity, where people from a variety of different cultures, genders, ages, professional backgrounds and disciplines can learn through collaboration, creative exploration, quite a bit of productive discomfort, and the joy of designing, building and analysing systems in a holistic and cybernetic manner. So our students are exposed to frameworks for questioning the new branch of engineering, a set of questions, for example, about 3As and Is, autonomy, agency, assurance, interfaces, indicators and intents, and a range of perspectives to thread these through and interrogate, design, build and decommission systems by thinking about and physically constructing all of the different sensing, acting, data, networking, infrastructure algorithms and learning components that form them. So that's the context and genesis, and now I'm going to go and briefly outline the structure of the program and how it runs. So the Master of Applied Cybernetics is made up of 4 courses this year. It's a 48-unit program, 2 that run as complementary semester-long courses and 1 as a year-long course, and I'll go into each of these in a bit of detail. So the first course is framing questions about cyberphysical systems. This course runs in the first semester and it's one of the introductory courses that aims to give students exposure to a range of different conceptual approaches on the new branch of engineering, and it draws on cybernetics and systems and control theory, lots of design thinking, lots of different methods from the social sciences, futuring, the humanities and a lot of critical theory. And through the course, we aim to challenge students to take different approaches to studying and understanding cyberphysical systems and how they can bring together a range of analysis methods and physically build and construct some ways of analysing those. The second course, which runs all year, is Building Cyberphysical Systems, and this course is aimed to be very hands-on and to support practitioners in how to understand new and emerging technological constellations and all the different components that make those up. So the students complete a range of lab-based projects, both an individual and a group-based one, to develop a technical understanding of systems as designed objects which embody a whole range of values. And the idea of this course is not that students will come out of it as qualified programmers or roboticists or computer scientists, but instead it's very much a course about learning by doing, where participants, we hope that they will gain sufficient knowledge and empathy with this kind of building practice to be able to drive meaningful and accurate conversations about these technologies and to shape design decisions as part of interdisciplinary teams who are developing new and emerging technologies. And then in second semester, we have the follow-up from our question framing course called Cybernetics Practice for Cyberphysical Systems. This process is very much about continuing to deepen investigation and analysis of cyberphysical systems using a range of different cybernetic approaches, and it's particularly linked to industry engagement. So students undertake industry engagement processes with a range of our partners and are able to use many of the analytical skills and cybernetic tools that they've been developing through the year. The last component of the program for next year is what we call Applied Cybernetics Experience. It's a 4-week engagement, or up to 4-week engagement with an industry, community, government, startup or academic organisation to start to put in practice some of those tools that students have been learning as part of the new branch of engineering, and to contribute to some projects related to cyber-physical systems. Now this is an element that doesn't count for units but is compulsory in the Masters. You may have noticed we also have the possibility of doing a longer engaged research project with any of these groups and many more partners who we have under what's called the Master of Applied Cybernetics Advanced. And so there's an additional subject there called Projects in Applied Cybernetics that can run over 6 months to do more engaged research with these partners and others. And the Masters, the 48-unit version, is an entrance requirement into our cohort-based PhD program. So I'm also happy to answer questions about that. So that's it from us. Hopefully you've already found all of our contact details. I just wanted to say thank you very much for coming along today, and we'll close this little bit of the presentation and then we'll start with our Q&A. So thank you very much, everyone. All right, so in terms of our first questions then, we have when will this program iterate to allow motivated full-time practitioners to pursue a part-time study? That's an excellent question, Roland. At the moment, we're developing a whole range of different options. We have in the new school an educational experiences team who is developing a range of offerings that we hope will be part-time. This particular instance of the Masters program, we will have to see where we take that, but we do see there is space in the market for part-time study. So we are seriously looking at those options for sort of 2022, 2023. And in terms of related seminars, again, that's a great question. We do have a range of different seminars, and we will, if you get onto our mailing list, there's lots of opportunities. I think with COVID, some of those have been a little bit reduced, but we'll have to look at our online offerings at the moment. All right, other questions? Management cybernetics, i.e. Stafford Beer covered and critiqued. So yes, management cybernetics is one of the aspects. We also look at a lot of the architectural and design cybernetics, some that come from biology, looking at some of the second and third order versions, and also critical systems theory. And the program is designed to not use those as is, but to develop a critical approach to thinking about them, thinking about if they're still applicable in particular settings. Did anyone else want to say anything about any of those questions before I move on to the next slide? No? Minnie, you're okay? All right, what have we got? Would someone having a completed PhD be able to pursue a research topic, converging people, AI, cyber and business within the program? If so, how? Through a PhD, fellow, special projects and others? So I'm not quite sure whether I've got this question right, but so you can do a PhD program with us after having completed the Masters, and absolutely we suggest that people do converge all of those different ideas, and we've certainly got a PhD student this year who's looking at a business related entrepreneurship topic with the AI cyber connections. And then we're always interested in conversations with partners to see if there are other ways of working with you, either sort of before or after PhD. So please just stay in contact and we can have a chat about those. We have a question here about what type of work roles would lead from this degree, and what practically would it prepare someone for doing. This is one of our key. This is one of the key questions that is dealt with through the practice course. And Zena, I don't know whether you would like to explain some of our approach to allowing students to develop their own pathways and supporting them to find a range of roles that suit their previous experience and what they've been adding. So I might hand that one over to you, Zena.
Yeah, no problem. I'm happy to answer that one. So the interesting thing about being a part of developing a new branch of engineering is that it is a new branch of engineering, which means that there aren't specific jobs that you will see that are directly aligned to the new branch of engineering. You know, it's something that we're trying to teach into existence. However, that doesn't mean that this is not a job-ready master's. So one of the things that we do throughout the year is we have workshops that we run throughout the year, and we do those in collaboration with our students. And part of those workshops is that we work with our students to communicate the skills that they do have, and then the skills that they've developed across the year throughout the master's program. And we work with them in communicating those skills to a potential employer, and we work with them to identify what potential employer they would want to work with. So what kind of market do they want to work in? What kind of job do they want to work in? What kind of skills do they want to pursue outside of the Masters? So we do workshops across the year that support our students in coming up with that narrative.
And then we've had some great examples of where our students have been working with some of their industry partners, for example, through their projects, and then they have been employed into those both internationally and across Australia into those kind of roles that they've been looking at. So that's why it's an integrated program with those industry engagements that start very early on, from after the fact you've just done one semester, and then we get you to start engaging to help with leading you in directions that you're interested in going in. All right, is there a syllabus available outlining the specific learning outcomes and skills gained? Yes, absolutely. So on the ANU Programs and Courses website, you should be able to see the ANU Master of Applied Cybernetics, and inside that there are the learning outcomes for the program. There are each of the courses that are included in it that have those individual learning outcomes. So all of that is available on the ANU Programs and Courses website. Is the program partnered with the wider cybernetic community outside of Australia? Yes. So we've recently participated in the International Systems Sciences Conference, and we have good connections across the world into a number of those different cybernetics and systems communities, and it's something that we're continuing to grow and work with other Australian cyberneticians as well. Did this program used to be fully supported by scholarships, and how many scholarships will be available for next year? In our first iterations of the prototypes, all of our students gained scholarships. As the programs now become more mature, there will be scholarships available next year. There may be a certain number that will be available. They won't be to the same level as our previous scholarships, but they will be available to support some living requirements, and they will be given out based on equity and application processes. So once people have applied and been accepted to the Master of Applied Cybernetics, we will let you know all of the different scholarships that you will be able to apply for to help you with your particular situation. All right, how much interaction is there with other schools at ANU? e.g. philosophy. So this program is run out of the School of Cybernetics, but we have people from all across the campus who are involved in delivering different components. So particularly out of the Research School of Social Sciences, which is where philosophy is based, we have people out of archaeology, out of sociology, and others who are involved. We have had good interactions, and we have one of our students who is about to start a PhD over linked between us and philosophy, and another international partner. So there are lots of opportunities for those, and we also engage with many of the university-wide initiatives around technology and artificial intelligence. As a follow-up, is there any chance that you could give a follow-up and maybe elaborate on some of the roles past students have taken through the partner program? What are some examples of what they would do in their roles during a day of work? That is a huge question. Yes, so we've had students who have gone on and worked in some major companies, open source companies, for example. Some of them have been helping to develop voice assistants that don't use, say, English, for example, and are working on some of those. So some people will go into roles where they'll be using their original skills, but in a new domain. We've had students who have gone into international sort of think tanks and futures institutes, who will then be doing a lot of sort of scenario work and engagement with media and others. We've had some students who have gone back into consulting, back into government to be working with policy. We've had people who have gone back into the army and who are now leading some of those cyber-physical systems related initiatives. So it's really diverse depending on who our students are and where they go back to. So again, like most of us, the days are full of all sorts of different activities. How does this Masters fit into the Commonwealth research funding structures? Does it fit within research scholarships? So yes, this is a traditional, it's under the normal ANU and Australian Masters programs. So any of the typical scholarships that you can get through ANU for any other Masters, you are also able to apply for this one. And the fees are all very similar to all the other ANU Masters, so there's nothing particularly special there. Would relevant applicants be required to complete a GMAT exam with their application or upon request? So depending on where you come from and what your background is, we have multiple pathways into this Masters program. We expect all applicants to have at least 3 years of professional experience. The reason for that is that it's only a 48-unit Masters, so we have to make sure people are at a particular level. That means that if you haven't had previous degrees or other things, yes, you may be required to take the GMAT to make sure that you're eligible for the program, and we would look at every single application and you would go through the process of application, and then we would help you to figure out your pathway to entry if that was the case. We are happy to take specific questions about any of those different components of the courses if you had more specific ones. All right, well, if there are no further questions, please do reach out to us. We're always happy to respond to questions by email. And if you have more in-depth questions, then again, oh, here we go, we do have one. Is the fee structure for each unit similar to other Masters programs at ANU, or are there differences because of the uniqueness of this course? No, we follow exactly the ANU system. So it's a 48-unit Masters, which is 1 year equivalent of program, which means it's the typical 1 year fee structure of ANU. Where can we find examples of capstone projects, white papers, publications, preprints, or general examples of work outputs from the program? So one of the best places for that is on our website and on our social media, both on Instagram and Twitter and LinkedIn and Facebook, I think, as well. There are lots of different examples of the student projects, some of the emerging publications, some of the white papers they've created. There was one recently, I think, that was profiled on dignity and AI. By one of our students. So many of those are on the website, and it's probably, if you would like to have a look at them, go trawling. And then if you have very specific questions about partners, then again we can answer those offline. What is the relationship between the school and the 3A Institute? So the 3A Institute is it's one of the what's called activity clusters of the School of Cybernetics. And the School of Cybernetics has a number of other areas, strategy, design, and systems that are all in development. So all of the activities of the 3A Institute are continuing, but they are underneath the School of Cybernetics now. And so Zena, Mina, and I are all members of the 3A Institute in the School of Cybernetics. Okay, well, unless you're all very rapidly typing, we will wait one more minute in case you're currently typing questions. We would like to thank you very much for taking the time to come and participate in this webinar. All right, we do have one more. Great. What percentage of the new branch of engineering has already been created? So we're getting closer to understanding the kinds of skills and knowledge that are required, and I think this is why in our 4th year of teaching this program into existence, we're getting a much clearer idea about some of those. Obviously, there's still a lot to be done, and so every cohort who comes in brings their skills and perspectives, and it's going to take time to figure out all of those different roles that are going to be required to create those safe, sustainable, and responsible cyber-physical systems. We will need to have lawyers and economists and all sorts of others who are able to engage with those systems, as well as our computer scientists and roboticists. So there is a lot more to do, and we're always looking for people with interesting backgrounds to come and build the new branch of engineering with us. It won't be set like many of these other disciplines that are still emerging. They haven't stopped growing and changing either, and so you will be part of the first years of setting up this new branch of engineering, and there's a very long trajectory for it to take over the years as we slowly get to know these technologies and their impacts on the world. Are most students looking for a career change or looking to further skills in current careers? I think that really depends on the students. We have a good mix of both. Some people come to the program knowing that they're likely to go back into their current positions, and then other students come looking for something to take them in a different direction. And so we attempt to support both of those trajectories. And the work that Zena's doing in the practice course is very much about understanding people's values and where they want to take their careers, and then helping them to build the skills that they're going to require to make the most of those choices. And that's the same thing through the build course, Mina. I don't know whether you wanted to explain the cyber-physical systems projects that people get to work on systems that they feel passionate about and work with others on systems they feel passionate about, and that a lot of those experiences can translate directly or be new directions for those students.
Yeah, sure, I can add to this. So through the build course, which goes across the 2 semesters, at the end of semester 1 and 2, there are different projects. One is individual and the second is a group project, where you build a prototype of a cyber-physical system. And the idea is to get many different voices and backgrounds to collaborate on a specific project where they have some expertise and different expertise and backgrounds and passions, bring this to life and think of how to take it to scale. And through doing this, there is a lot of exploration of possibilities of this helps students in exploring where they want to go next, or where their passions are in relation to new technology and new AI-enabled cyber-physical systems. So it opens up a lot of opportunity to knowing better about the technology and the underlying AI, and to understand these in order to take it further to either a different or a shift in your career, or to take your own job that you had before to a next level, looking at different things from different perspectives.
And we have found that there are many students who come in expecting to go in one direction, and then after a few months with other students, they find new passions that they didn't realize they had. So we may, for example, have lawyers who end up becoming artists because they really enjoy that engagement and that creativity. We may have people who have previously worked with a lot of data analytics who then realize that they love making and engineering. And again, creating. So I think it really depends on the people and the skills they bring, and then what they learn in the program and how that transforms them. So some people will have very different experiences from others, and they'll have different things that they're looking for out of the program. There's a lovely comment there about improved cybernetic style. It seems a lot of the school is emerging, absolutely, and that is something that we take as a part of the program that we want a lot of that creative emergence. You may have noticed I talked about productive discomfort, that idea of respecting all of those different views and perspectives and then letting new and interesting and helpful properties emerge from that system of students and those cyber-physical systems that they're creating. That is part of the kind of the genesis and the DNA of the program, is to have that emergent property. We have one here about the guess that the general public won't understand the term cybernetics as easily as AI or something more common. And is this a problem, and how do you overcome this? We see it more as an opportunity. I think many of the conversations about AI focus on some of the challenges of AI. They're either very dystopic or utopic. And one of the ideas about using a different term like cybernetics is to think about those interactions of machines and humans and environments and how all of those interrelate, rather than focusing purely on the technology. So it gives us a lot of space to create this new branch of engineering without being as stuck in some of the previous discussions that tend to be very focused either in particular geographies or in particular focuses. And the lovely thing about it is it's a very old term, but that has lots of opportunities for it to be reinterpreted and used in ways that make sense to people. And we have found that it's resonated fairly well with people. The idea of cyber is something people hear a lot about, but understanding that cybernetics and that idea of feedback and interconnection, the challenge, I think, with complexity in today's world, cybernetics allows us to get at that complexity rather than continuing to break things down into tiny little components. So that's one of the reasons behind it, and we've found that it's resonated pretty well, and some of even the big companies are going, oh yes, this is actually what we need. So there's increasing interest in both the term and in the program as well. Are students involved in choosing which things get taught during the program? That is in some ways a trick question, because students are also involved in teaching components of the program. Zena and Minna, I don't know whether you wanted to explain, and I can also explain from the Framing Questions course how we go about bringing students' skills and experiences into the program. Minna, did you want to start with the skill sessions and studios and how we engage our students that way?
Yeah, sure. So part of the build program is student-led sessions where we ask students to teach the cohort based on their experience and expertise and their previous careers and passions and interests. And in doing so, there is a lot of skills that emerge and there is a lot of shaping of what the course is teaching to the other students in the cohort. There is also a second opportunity where we decide at some point, because a big component of this course is machine learning and artificial intelligence, there is a point in time where we all have some sort of agreement on what aspects of machine learning we want to be teaching in the course. And this is definitely a student decision that's done over the course.
And in the first semester in the Framing Questions course, which is linked very much to the build program as well, as we have a common set of resources, or we did this year anyway, where students are provided with that common set of resources, and they help to analyse and bring their own perspectives to those as well. And so they'll be paired up to help navigate those resources only once during the semester. And so you have groups of students who will support the learning of the other students. And many have found that both a really beneficial thing for themselves and actually wanted to repeat it the second semester and asked us, can we do something like that? And we said yes. But it's also a way of getting deeper into the different bodies of literature and strands that link to the cybernetic theory, but then also having deeper knowledge across the cohort. So it's very much a cohort experience where each student can then rely on the rest of the cohort. They don't need to learn everything themselves. They can have a reasonable understanding of many things and then go much more deeply into some areas that really interest them and learn about how to work with those multiple perspectives. Where does the school's cybernetic direction sit in relation to AI safety work, e.g. interpretability? So safety is one of the areas that we're involved in. I know we did have someone working on one of the international groups looking at AI safety. Minna, I don't know whether you know any of the current work that we're doing there and whether any of that's being taught into the program or whether it sits more in our research components. Or maybe Zena as well, feel free to.
I think it's a bit of both. There is a component of the build program about AI and safety when it comes to AI. I think mostly it's in research though, like I don't want to be misguiding here, but it's mostly happening in research with a little component happening in the teaching of the masters around AI safety. Yeah, I think that's it.
Zena, did you want to mention some of the aviation part?
Yeah, sure. I will also say that we do touch on safety in the practice course as well, but we touch on it from more of a theoretical perspective. So we do look at things like trust, assurance, and risk assessments. And then from an aviation perspective, we do a little bit of research around software safety. So Catherine, myself, and another one of our School of Cybernetics members, Noel, did contribute or did collectively work together on a particular research project around the safety of software systems of autonomous aircraft.
Thank you for all your questions. Great questions. Just wait another 30 seconds in case anyone's rapidly typing something. All right, well, in that case, for those of you who are in Australia and in lockdown, we might give you back 15 minutes for a quick break from Zoom and some lunch. Thank you so much for joining us again today. We've enjoyed all of your questions and we hope to see many of you through the application process and into next year. I do see there's one extra question. How difficult would it be to transfer PhD programs into other departments? This can always be done. At the ANU, there's a lot of transferability, same thing, sometimes between universities, although the scholarships can get a little bit tricky. But otherwise, there are opportunities for moving around. And we've had a number of our students who have gone and done PhDs. We tend to take a certain number into our program and then there will be others. So we've had people go, as I mentioned, into philosophy, into sociology, into computer science so far out of our first couple of cohorts. And then people who have taken PhDs overseas as well. Political aspects of cybernetic studies or autonomic systems as part of national policies. Yes, so we do have a pretty strong political and politics view, like we look at sociology and anthropology and archaeology and others. So they come into some of the frameworks. We've had a number of students who have gone and done policy-related projects for their research projects later on. Particularly for this next cohort, it would be if you do the Master of Applied Cybernetics Advanced, but we certainly touch on a number of the different political issues as we go through, and also international politics and legislation, including some of the European, what's going on in Europe and what's going on in the US and other places. Is this degree recognised well overseas? Would it be difficult to transfer into PhD programs at overseas universities? We've had a really good response from overseas universities with our graduates. So from that perspective, it is seen as being a world-leading program. Showing it recently in the cybernetics community, it had a very strong response as well. So depending on what kinds of areas you want to go into, it is very well recognised. All right, well with that, thank you so much to everyone. Anna and Kate, did you have anything that you wanted to mention on the administration side and when applications are due and how to use the platform, etc.?
Just in general, applications close on the 31st of August. So there is a link on our website. So if you look for the Master of Applied Cybernetics, it will lead you to a 3AI website where you can apply. So please don't go through the ANU website at this point. Once applications close, we will reach out to potential students within a couple of weeks, so you will know if you've been selected for interview.
Great. Well, thank you so much, everyone. We hope you have a lovely day and we hope to see you through the application process and beyond. And please do stay in touch if there's anything that we can help you with that's non-masters related as well. Thank you so much, everyone.